Today we are writing equations in standard form. When writing standard form, we use the equation ax plus by is equal to c. So there's a couple rules that we have to follow. The numbers, the coefficients a and b, along with the constant c. No decimals can be used, no fractions, and no mixed numbers. So we are going to have to manipulate the equation a little bit as we go forward. The other part of that is that x and y terms are on the same side of the equation. So we have ax plus by is always going to be on the same side, is equal to the constant, which is on the other side. A is our coefficient for x. We usually see that as a positive value. And the other thing is standard form cannot be used for graphing. Let's look at our first example. So it says y is equal to negative 2x plus 5. And I want to make sure that I have this in standard form. So here's my wall, and I need my x and y on the same side of the equation. So I'm going to add 2x to both sides, and I have 2x plus y is equal to 5. So that is in standard form. I have x and y on the same side. I don't have any fractions or decimals, and my a value, my 2, is positive, which is what I like. So I'm good. Number 2 is a little more difficult, a little more challenging because I have a fraction. So I like to just get rid of the fraction first. I know I don't need it. My denominator right here is 4. So I know if I multiply everything by 4, that's going to help me get rid of that fraction. So I have to make sure I'm multiplying 4 by every term. So 4 times y gives me 4y. Then I have 4 times negative 3/4 x gives me negative 3x. And I also can't forget to multiply 4 by negative 6. So that gives me negative 24. So in this step right here, I got rid of my fraction. So the only thing I have to do now is get my x and y on the same side of the equation. So again, there's my wall. I'm going to add 3x to both sides. And I have 3x plus 4y is equal to negative 24. So I have no fractions, no decimals. My a value, my 3 is positive 3, so I'm all set. That equation is now in standard form. Let's look at our next example. It says write the equation in line in standard form. So again, it's telling me standard form that passes through the given point and has the given slope. So I'm taking an equation of a line and I'm given the information. I have the slope is equal to negative 2 and the point that I'm working with is negative 4, 3. Now I can't go right into standard form using this information. So I have a point and a slope. My point is not my y-intercept, so now I have to use point slope form first. So remember that's y minus y1 is equal to m times the quantity of x minus x1. So this gives me y minus 3 is equal to the slope is negative 2 times the quantity of x minus the negative 4 is x plus 4. All right, so this is PS, that's point slope. Okay, now I need to distribute my negative 2. I need to get rid of my parentheses. So I have y minus 3 is equal to negative 2x minus 8. Now from here, some students think that they have to go to slope-intercept form first and then standard form, but that's not the case. I can actually just go from point slope to standard form. So I'm going to add my 2x, and I have 2x plus y minus 3 is equal to negative 8. So I'm almost there. I'm almost at standard form. I just have to get that 3 on the other side. So in standard form, my equation of the line that passes through the given point and has the given slope is 2x plus y is equal to negative 5. The next example says write the equation in standard form that passes through the given points. So at this point, I don't have the slope like I did in the last example. I'm going to have to find the slope. But always my next question is, are either of these points my y-intercept? And in this case, I can say that 0, 5 is my y-intercept. So let's first find the slope. So I have slope is equal to 0 minus 5 over 2 minus 0, which gives me negative 5 over 2. That's my slope. Because I have my y-intercept, I can go right into slope-intercept form if I'd like. So I have y is equal to negative 5 over 2x plus 5, right? Because here's my y-intercept right here. Now again, this is slope-intercept form. I need to get that in standard form. And again, I notice that I have fractions, which I can't have. So I'm going to have to multiply everything by the denominator there, which is 2. So that gives me 2y is equal to negative 5x plus 10. Remember that 2 had to be multiplied to every term. Now I'm getting closer again. There's my wall. I need to get my x and y on the same side. I'm going to add 5x to both sides. And I have 5x plus 2y is equal to 10. So I have my x and y on the same side of the equation. My a value is positive. I don't have any fractions or decimal, so I'm all set. This problem, we have the same directions as the last problem. Write the equation in standard form that passes through the given points. The difference in this problem is neither of those points are my y-intercept, so I know I'm going to have to use point-slope form. First, I'm going to have to find the slope, so I have negative 1 minus a negative 7, which is plus 7. And then I have 5 minus 4. So my slope is 6 over 1, which is 6. Now to use point-slope form, I can use either point, doesn't matter. I'll use the first one. So I have y plus 7 is equal to 6 times the quantity of x minus 4. Again, I have to distribute to get rid of my parentheses, so I have y plus 7 is equal to 6x minus 24. Now, I know if you notice, my a value here is on the right-hand side. That's positive. I want to keep that positive, so there's my wall. So in this particular problem, I'm going to bring y to the right-hand side, and I have 7 is equal to 6x minus y minus 24. I'm going to add my 24 so my constants are all on the same side. So I have 31 is equal to 6x minus y. That is in standard form. If you like to rewrite it so x and y is on the left-hand side, that's fine. 6x minus y is equal to 31. That's my final answer in standard form. And looking at the graph, our directions say write the equation of the line in standard form. Now remember, standard form is ax plus by is equal to c. Now this one's a little different because it is a vertical line. Now remember, when we were talking about this earlier, vertical lines are evux, right? Vertical lines have an undefined slope and x equals a particular number. So in this case, x is equal to negative 2. Everywhere in this line, there's an x value of negative 2. That's how we write the equation for a vertical line. There is no y value there. So this actually is already in standard form. So at that point, we don't have to move anything around. We're all finished. We have the same direction for this graph. Write the equation of the line in standard form. In this case, we have a horizontal line, so that's a HOI. Horizontal line has a 0 slope, and its y is equal to a value. So in this case, y is equal to positive 3, because everywhere in that line has a y value of 3. And again, if I'm looking at standard form, ax plus by is equal to c, I don't have an a value here. Actually, my coefficient for a is 0. So my equation of the line y is equal to 3 is already in standard form.